I'm Anil Kumar, and here is a very interesting example on factoring with the help of difference of squares. Question is, find all possible combinations of a and b if a square minus b square equals to 48, where a and b are natural numbers, right? So we need to find all possible natural numbers whose difference of squares is 48. So that is another way of looking into this question. I'd like you to pause the video, answer the question, and then look into my suggestion. So what we have here is that difference of squares of two numbers should be 48. Now what we can do is we can start with analyzing 48 itself. Now how can I get 48? Let me write down factors of 48. 48 we could get by, let us say, 48 times 1. We could also get 48 by 24 times 2, right? So 24 times 2, we could get 48. So these are different possible factors, right? If I have to divide this by 3, what do I get? I get 16. So we get 16 times 3, or we could get 48 by 4 times 12, right? So 12 times 4, and we could also get 48 by, the other factors are 6 and 8, right? 6 times 8 is 48. Let me write the bigger number first, 8 times 6. So these are possible combinations which can give us 48 as a result. Now, what we will do is we'll try to write them as sum and product, right, of two numbers. Now, I will show you how. If I do 48 and 1, then it is 49. Half of 49 is a fraction, so we'll avoid that, right? So we'll avoid that. Here we have 24 and 2. If I add, it is 26. Half is 13, right? So half is 13. So think like this. Half of this is 13, so we could have 13 as a sum, right? And then some number which can give us 2. Okay, so 13 minus 11 is 2. You get the idea? 13 minus 11 is 2. So we could write this as 13 square minus 11 square. Now this is a very tricky part. How did I get 13? I got 13 by adding 24 and 2 and then dividing by 2, right? So I could get 13. Basically what I'm trying to say here is that I could write 24 and 2 as, look here, 13 plus 11 times 13 minus 11. Now I think the strategy will be slightly more clear, right? 13 minus 11 is 2 and 13 plus 11 is 24. You get the idea, right? Okay, we'll do with another example, then figure it out. 16 plus 3 is odd. So when you add, let me write down here. 48 plus 1 is 49. So that is odd. So we'll reject that part. Now here 16 plus 3 is 19. That is odd. So we'll reject this one also. We'll not get a combination. But let's try this one. 12 plus 4 is 16, right? So let me show you the strategy here. So what I did was I added 12 plus 4 and then I divided by 2 to get my first number. So 12 plus 4 is indeed 16. 16 divided by 2 is 8. So what I did was I said, okay, 8 square is my first term, right? Now 8. 8 plus what is 12? 8 plus 4 is 12. Good job. So my second number should be 4, right? And 8 minus 4 is 4. So I say 8 square minus 4 square will work. So that is how I am getting my numbers. I'll explain you once again this strategy, okay? So what we get here is 8 plus 4 times 8 minus 4. You can see 8 plus 4 is 12 and 8 minus 4 is 4. So we get 8 plus 4 times 8 minus 4. It could be factored. So our A and B's are 8 and 4 in this case. Now, if you have understood the strategy, can you apply for the last one? So what am I doing? My step number 1 is, step 1, let me summarize. Add these two numbers, 8 plus 6, divide by 2. Now 8 plus 6 is 14, divided by 2 is 7. So if you get a natural number, then you can get a solution. Otherwise, there is no solution. So we say, yes, we have a natural number 7, so we have a solution. Right? Now, think like this. 7 plus what is, do you get 7 plus something as 8? Yes, we do. So we can write 8 as 7 plus 1, and we could write 6 as 7 minus 1. You get the idea, right? And therefore, I'm saying, when you multiply these two, this could be written as 7 square minus 1 square, or 1, right? Or I'm just expanding and writing here as, to show you this answer, 7 plus 1 times 7 minus 1. Do you get the idea now? So I've actually applied the strategy in different ways so that you can understand. So different solutions for us are, one is A and B could be 13 and 11. So one is, the combination could be 13 and 11. The other combination which we got is 8 and 4. I mean squares, right? So actually I should write squares, 64 and 16, right? And then we got 7 square and 1, correct? So these are my A's and B's, right? So 13 is my A, B is 11 for the first set, right? This is my first set, and then I have a set which is 8 and 4, and then I have a set which is 7 and 1. So A and B values are 13, 11, 8, 4, or 7, 1. So that is how we can get different values or combinations of A and B, so that A square minus B square is equal to 48. I hope you understand and appreciate the strategy. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.